All right. I'm going to share now. Okay, here we are with the document pulled up. It should be a PDF that I sent you. All right, I'm gonna bring it up a little bit.
You have a question about how the test is being administered?
Electronically, just like your other tests. So your test 3, it should be the same. Okay. All right. It's gonna look exactly like it. Can everybody see that very well? Is that large enough? Yeah. Okay, good. All right, let's see how this thing is gonna work. I don't know, it's gonna work. All right, so I haven't even tried to write on this thing. Let's see if it'll let me. So this first thing, and I might have to open up a whiteboard on the side just to go ahead and write on a blank sheet of paper. But how many people have gotten through, say, the first part? So you notice there's a part 1 and a part 2. Did we kind of get through the first part of the problems? Okay. Did anybody have any major issues? Like what problem really gave us some real things that we couldn't really remember? Kyle, Dakota, do we have any issues or any problems that really gave us any trouble?
Kyle says 8.
Number 8, okay. Anybody else? How many people haven't really quite gotten to the problems yet? We can be honest. Thumbs up on it. Oh. Hold on for a second. It might work itself out. Oh. No, it worked itself out. Okay. I'm washing my contaminated clothes, y'all. But I was outside. Okay. All right. Okay.
Ross would like to see 2 also.
Number 2, we haven't seen that one for a while. Okay, that's a good one. All right, so let's go ahead and we'll start working with it. Let's see what happens here. Initials. Let's see if it'll let me do what I need to do. Okay, I think what I'm going to do here is I'm going to bring up where is my for a sec. I wonder if I could share 2 documents at the same time. Oh, optimize. Okay. So here's what I'm going to do. Since this is going to be better for me. I'm going to bring up this whiteboard. It gives me more options to write. And then you have your documents in front of you. Is that correct? Yep. Okay, I'm going to flip back and forth here. So here's my document. We're going to go ahead and just work through our problems, ask our questions as needed, all right? And you let me know when you have a question. All right, so number 1 says sketch the graph of f of x equals negative 2x plus 1. This particular problem will come possibly in a multiple choice selection. So they'll give you 4 graphs to look at. You still need to know how to graph this on a number line. So when you look at it, Here's number 1. You're going to draw your graph. And we have f of x. Now remember, f of x is the same as y. So negative 2x plus 1. Remember, we always start with our y-intercept. So remember, this is slope-intercept form. Y equals mx plus b, and b is our y-intercept. So our y-intercept is plus 1. So here, putting some points on our graph, give us something to guide us. All right, so we're starting at positive 1 with our first point. And then our slope tells us to go negative 2, and then feel free to put it over a 1 to make it a fraction. Remember, rise over run. So starting with our positive 1, it's our starting point. We're going to go down 2, over to the right 1 to make our second point. Remember, feel free to do this as many times as you like, but you're going to look at the graphs that they give you, and you're going to see which one corresponds to this. Here is my second point. From here, I can make my connection and draw my line, which is going to be a negative line. Okay, now watch this now. Right off, by looking at this, I knew, and you should have known too, that this was going to be a downward sloping line. Why? Because my slope is negative. Okay, you remember that? I didn't even have to draw the graph. Because my slope was negative, I knew that my line should be doing a downward motion. So if this is a multiple choice selection, you should be focusing on the line that's going to go down. Any other line that's not going down can't be your answer, okay? So you can rule out some answers that's not going to be your answer, just from that. And then you know it has to go through a positive 1. You can rule out some answers for that. So think about what we know. We know it's got to go through positive 1. We know that the slope is negative and it's going to be a downward sloping line. So here, starting at 1, we go down 2, over to the right 1, and make our connection. Any question with drawing out or sketching out our line? All right, moving to our next one. Number 2 says, use the graph to evaluate f of negative 2. All right, so here's our graph. There's our line. They want us to find f of negative 2. Remember, inside the parentheses is our x value. They want us to find the corresponding y value. So we need to go to our graph where x is negative 2. So here is 1, 2. That's negative 2 right there. And then we're going to go down to our picture right here and line it up with our y value. And that value is what number? What does it line up with? No response?
Kyle and Ross say -3.
That's it. All right. So all you have to do is just find the lines, okay? Follow the lines. So if you see this on your test, find where x is negative 2 or whatever number they give you in those parentheses, then go to wherever your graph is. It might be up above, it might be below. Here it's below us. And then you're going to look to see where that y value lines up. And there is -3. So number 2 is -3. All right. So remember, a lot of our stuff is plug and play. They give us a piece of something, we got to find the missing part. Same with number 3. They give us this function, f of x equals this polynomial. They want us to find, again, f of -2. Here they want us to simply take -2 and plug it in for our x values. And then put it into our calculator. Now remember, we put this whole entire thing in our calculator. Use your parentheses functions. All right. But if you don't want to do that, just simply plug it in and work it individually. So here's our parts. So we have number 3. Now watch it now. They're always going to try to lead you off with some funky looking thing here. Okay, watch this. They'll lead you off with a negative number and a higher exponent. They want you to mess this up because they're always going to usually give you a negative number to plug in. So do your dry plug in first on your paper and then put it in your calculator. That way, when you put it in, you know exactly what it's supposed to look like. So we have a negative 2. Then we have a negative 2 we're plugging in, raised to the 3rd power, right? Then we have plus x, but then we plug it in. Use your parentheses, okay? Always use your parentheses when you're plugging in. Then we have the plus 3. Always give you a scraggly number on the end. There's my plug-in, right? Always use parentheses to plug in your numbers. It keeps your signs straight. Now we're ready to evaluate. Remember our order of operations, we got to do our exponents first. So if you're putting this in your calculator, it should look just like this with parentheses and everything, okay? But if you're not doing your calculator, go ahead and let's do evaluating now. Negative 2 raised to the 3rd power should give us a negative number. And that should be what?
Got some people that think it's -8.
I think so too. So negative 8 times a negative 2 is going to give me a positive something. The chat says
16.
So 16. Then we have this negative times a positive is negative 2 plus 3. Now we're cooking with gas now, right? We're ready to go ahead and wind it up. So we get 16 minus 2, which we know is 14, right? Then 14 plus 3. Did you get the same number I'm getting? I think so. Yeah, you got that. So we got 17. Is everybody all right? So make sure that we are paying attention to our signs. That's going to get us every time. But if we get those, use those parentheses to do our plug-in, that is going to help keep us straight. All right? And make sure that we don't let that mess us up, because that's going to get us. But those parentheses should help keep us straight. Is everybody all right with 1 through 3? Yeah. Okay. Here we are, number 4. We're evaluating. So evaluating, they're going to give you something raised to a negative exponent. How do we get rid of a negative exponent? We got to flip it over, right? So here we have 7/6 raised to the negative 2. So number 4, 7/6 raised to the negative 2. In order to evaluate it, we have to flip it over first. So 6/7 now raised to the positive 2. And then now we can evaluate it. Now we can say 6 raised to the 2nd power gives us what? So our final answer should be bless you.
Thank you.
So we get, somebody's telling it.
Several of them got it now.
So we get, I can't see it when I'm writing.
36/49.
Okay, so 36 all over 49. Very easy 2 points there. Just make sure you got to get the flip in. That's the most critical part. All right. And then raise your answer to the second power. All right. Let's see what the next one says. We're evaluating with a radical now. Here we are taking that fraction, all encased in that radical, and seeing what happens. So we have number 5, the whole square root of this fraction. So remember, everything encased under a fraction works individually as well. So if it makes you feel better, split it up. So we get 16 over 25. So we get 16 all over 25. Remember, you can rewrite this as the square root of 16 all over the square root of 25, and then evaluate it from there. So when we take the square root of 16 over the square root of 25, that gives us what? What do we get?
Ayla says 4/5.
Okay, that's right, 4 over 5. Remember, it all comes out of the radical, so don't put it back under there now. Are we feeling all right about it so far? Now remember, you have some thumbs up, some things, right? You tell them where they are, Vera. I can't remember what they're called. They're motions,
if you
right?
look under participants, there's a yes and no button. And I don't see the able to raise your hand option.
I think there's a emotions button.
Oops, Kyle found it.
There you go, Kyle. See, Kyle's all right. It's down there. Play with that stuff, you guys. There's a thumbs up and a thumbs down and all that good stuff in there. All right? All right, here we go. Number 6, we're multiplying. And they want us to take this square root of 2 and distribute it inside of these parentheses here. So we have the square root of 2 for number 6. Square root of 2 times the square root of 8x minus the square root of 2. And we're distributing it. Now remember our rule that says when we're multiplying two radicals together, they're the same root value. So we're going to keep the root value and multiply what's underneath. And then simplify when you can, okay? Then we also learned a little shortcut in there. When you multiply the same root by itself, the same square root by itself, then it just kind of cancels out and just leave the same thing. So let's try it. So we have the square root of 2 times the square root of 8x. So that means that we have the square root of 8 times 2, which is the square root of 16x. Is everybody all right? All right. Then we have the square root of 2 times the square root of 2. Now here's the shortcut coming in. We know that the square root of 2 times the square root of 2 is just the square root of 4. The square root of 4 is just 2, right? But I'm going to put this intermediate step in just so we can see it. So we have minus the square root of 4. All right, so now I'm going to simplify. So if you want to go ahead and simplify while you're multiplying, feel free. It's whatever is in your comfort zone, do it, okay? So now I'm going to simplify my answer because I might be able to subtract, okay? So, but we won't know until we simplify. So here we have the square root of 16x. We see that 16 is perfect, but the x is not. So I can take the square root of 16, but I got to leave the x under there. So the square root of 16 is 4. But I got to leave the x underneath the radical, right? Then minus, and then I have the square root of 4, which I just know is the number 2. So my final result, 4 square root of x minus the number 2. I can't subtract here. They're not the same, okay? Is everybody all right? All right. Number 7, we're factoring. They want us to factor 2x to the third minus 18x. All right, number 7. 2x to the third minus 18x. Now remember, of course, when we're factoring, we always got to ask that first question. The first question is, do they have anything in common that we can take out of all of our terms? What do they have in common between these two terms? That will be called the greatest common factor. What is the greatest common factor?
I'm seeing an X and a 2X.
Okay, so we have an X and somebody said a 2X. So
Oh,
now remember,
they changed their, now they're both saying 2X's for you.
Okay, 2X. So now remember, when they don't have, now we're not solving now, we are factoring completely. So we kind of talked about the two differences. So he don't have an equal sign here. So we know that when they say factor, that means factor completely. So we got to see all the goodness. So all the goodness would be the 2 and the x. So we're going to take out a 2 and an x. And then we're going to write what's left. So what's left after we take out the 2 and x? Now remember, factoring is just like dividing, right? That's all we're doing is dividing out that common term. So when we take out the 2 and the x from our first term, that should leave us an x squared. Minus, taking a 2x from our second term here, 2 goes into 18 and leaves us what?
Everybody's yelling 9.
Oh, wonderful. All right, so it leaves 9 because the x is canceled, so we're only left with 9. Okay, so now we are here with 2x times x squared minus 9. Are we finished factoring though? Can we go further? Because remember, it says factor completely now. So we can go further. Okay, here we have this thing, x squared minus 9. That is a difference of 2 squares. That means we can go one more again. So now remember, when you're factoring, always make sure, you might be able to just do that one factor, okay, but look at your answer and see if it fits the criteria of other stuff. And here, it fits the criteria of a difference of 2 squares. We can go one more time. So this 2x still stays on the outside. And here, we can break up this x squared minus 9 into x plus 3 and x minus 3. Now we see that we can't go any further. Excuse me. So now we're finished. Our completed factored answer, 2x times x plus 3 times x minus 3. Any questions with 4 through 7? All right, we're doing good. Okay, here we are, moving on. Okay, let's look at number 8. Okay, we said we needed to be refreshed on this one right here. It says write the domain in step builder notation. Now this question might be asked in a different way. They might say, tell us the value of x that will make our denominator 0. Now, we know when we hear the word domain, that's what we're talking about, right? We're talking about that number or numbers that will make our fraction undefined. How do we find the domain? Do we remember? Right? How do we find it? What do we have to do to find it? Maybe I'll go on the next page.
They're telling you to set the denominator equal to 0.
That's right. Because remember the two D's, denominator, the domain denominator. That's your key. All right. So we're talking about the name. Now, it's nice that they give you that hint. So if on the test they say, find the value of x that makes your denominator 0, then that's awesome. They're telling you what to do. All right. So now we're going to set our denominator equal to 0. And our denominator is 3x minus 1. So we have 3x minus 1 equals 0. And then we got to solve it. So solving it, got to add that 1 over. So we get 3x equals 1. Then we got to divide by 3. So we find out that x equals 1/3. So we just found out that x can be any number in the world. It just can't be 1/3, right? So that's where we put our little slash through our equal sign, right? And we know that that's going to be the number that's going to make our denominator 0, all right? They want us to write it in set builder notation here. So remember, set builder notation is squiggly brackets, right? With our x. So we talk about the set of all x, right? Such that, and then x cannot equal 1/3. And then close it up with your squigglies. All right, there is our set builder notation. Is everybody okay now? So when they ask for the domain, we know what's going on. When they ask us for the value that makes our denominator 0, same thing, we know what's going on. All right. Number 9, solve. And they want us to solve for x. Now here's where that domain thing comes in. It's important. Watch it now. We're solving for x. So we get x all over x plus 1 equals 2. Here it is, 9. So we have x over x plus 1 equals 2. And they want us to solve for x. The common denominator. Do we see it? Now remember, don't think too hard about it now. We only got one denominator, and we know that that's our common one, x plus 1. Tell me, what is my domain here? Do we have it?
They're not liking -1.
All right. -1. Oh, I just found it. Ooh, I pulled up the chat. Wonderful. I can see it now. Okay. All right. -1. That's right. Why do we have to find it here? When we say solve, look at the keywords now. Solve is the keyword. Then we looked at our problem and we had a fraction. We know we hate them, right? Then our fraction had a letter in the denominator. When you have a letter in your denominator, that means that there's a problem. And we got to find it. And what that problem is, the domain. We got to find out what that restriction value is or what that domain is so that we know that if our answer comes out to be it, we got to cross it off. And we just found out that x can be any number in the world. It just can't be -1. Now we got to solve the problem. Our common denominator is x plus 1, and we can solve it. Now remember, if you're a cross multiplier, go ahead and cross multiply. If you want to multiply by the common denominator on both sides, you're doing that. All right, so you're doing the same solving technique. I'm going to multiply both sides by x plus 1 because that makes me feel good in my spirit, okay? But remember, whatever makes you feel good in your spirit, do it. Okay? Just don't use the force. You know that's not legal. Okay? But you got to use one of these legal ones. All right, here we go. We're multiplying. We know that these cross out and leave us just x equals. Then we have 2 times x plus 1, and we have to distribute, and that gives us 2x plus 2. Now we can finish solving for x. I think I'm going to go ahead and subtract the 2x over. Because, you know, I like messing with them negative numbers sometimes. But if you don't like it, make your x positive. Go ahead and do it. All right? But if you're one of them people who like to put your x on the left side because that makes you feel good, then you're going to have to make that x negative. So here we are subtracting that 2x over. And negative 2x plus x will give us a negative x. Is everybody all right? All I did was subtract this over. Negative 2x plus x will give me a negative 1x. But now I got to finish solving for x. So either you're going to multiply through by negative 1 or divide by the negative 1. So we get x equals a negative 2. Now, is this answer my restriction value or my domain? No. Now, if it had came out to be, then we'd have to cross it off. Then there'd be nothing left. Then we have no solution, right? But it didn't come out to be. I feel pretty good about my math. This is my answer. Is everybody all right? Okay. So as long as you're feeling good, you're paying attention to what you're doing with your signs, because again, that's going to get us. Making sure that you're changing your signs accordingly when you're moving across your equal sign. Okay. Write it out. If you can't do it in your head, write it. It's better to be safe than sorry. All right. And then after you get your answer, compare it to your domain. If it comes out to be that domain, get rid of it. And if there's nothing left, your answer is no solution. But here, it was close, but no cigar. That means our answer is negative 2. Is everybody good? Yep. Any questions about it? All right. So remember your signs. It says solve, fraction, letter in the denominator. You need a domain. Okay? All right. Let's move to number 10. Number 10 says simplify. And they give us this expression. It could be a simple expression like this. It could be a little bigger, bulky one. Again, remember, we're simplifying. It could be that you could simplify something. Simplify means to cut down, make smaller, get rid of. Remember, we cannot cancel anything over something that is being held together with a plus or a minus sign. That means that we need to factor some stuff, all right? Anything being held with a plus or minus sign is married. You cannot break that up. But if it is being held together by multiplication, that means that they are dating. You can break up dating. Is everybody okay? Okay, so here we go. We're going to write this thing out, okay? So we get x squared plus 2x. So x squared plus 2x all over this trinomial goodness right here. X squared plus 3x plus 2 plus, what did I say? 3x.
3x plus 2.
Thank you. Here's my problem. Now, whatever can be factored, you got to factor it. So factor is still going to be prevalent on this test. Remember, I said it's going to follow us all the way to the end. So here we are. We're factoring our top. Again, ask that first question every single time. Is there anything that we can take out that they have in common? The greatest common factor on the top, we clearly see, is an x. So we're going to take out an x, and we're going to be left with x plus 2. Sometimes it's going to be just that simple, y'all. It might just be one little letter. It might be one little number. All right, just make sure you be consistent. On the bottom here, we have a trinomial. All right, do they have anything in common? Nope. Then we're going to ask our supplemental questions. Is the first term perfect? Yes, it is. It is a perfect term. Is the last term perfect? No, it's a 2. So that means I just got to go all regular factoring with this one. So now if you're using whatever method you're using to factor your trinomials, you'll do it. Trial and error, using the AC method, if you're using the ninja method, if you're using the, oh Lord, help me get it right because I don't know method, do it. All right? But we just got to make sure we check it to make sure it turns out to be right. And that's where our foiling comes in at, to check it. So let's go ahead. We're going to do trial and error with this one. We see that they have nothing in common. It's not perfect. So I'm going to put my structure here. And I'm going to fill in what I know. I know for sure that x squared breaks up into x and x. And then I know for sure about the factors of this too. Remember, you're not writing the factors of your middle term. You're only writing the factors of your last term because then it's going to work with the first term to get the middle. The factors of 2 are 1 and 2. Since my leadoff term is a 1 x squared, it doesn't matter where I put these factors of 1 or 2. It doesn't matter, okay? So I'm going to put a 1 and a 2. That's all I got. Because now, either I got to add to get a 3, or I got to subtract to get a 3. And we know that 1 plus 2 is 3. So that means I got to add them things together. So I need both of these signs to be positive. Here I am. I'm going to do my verbal check with my FOIL. When I multiply these two numbers together, I get my 2 back. But when I add the 2 numbers together, I get my 3 in the middle. There's my check. Now, if you need to do the entire FOIL out, do it, okay? To make sure you get the exact same trinomial back, all right? So now, we factored. We've checked. Now we're ready to get rid of some stuff, okay? Now here's the cut down part. So now we're at the simplification part. Can we get rid of some stuff? We can get rid of this x plus 2's. They go away now. Let's see. It looks like we could get rid of these x's, don't it? But we can't. Why? Because this x is married to this 1. Can't break that up, okay? So what do we have left? Our final result. On the top, we have an x, and on the bottom, we have left x plus 1. There's my final answer. All right, so we've simplified. Make sure you check your trinomial factoring. Very important. All right. Number 11. Solve for A. So here we are solving for a specified variable, okay? Solving for a specified variable. They want us to solve for A, and here's number 11. It says MA equals Z minus 4A. So number 11. MA equals Z minus 4A. All right. Now remember, we're solving for A. Keep your eye on the prize. If you're solving for A, you want to get all the A terms together. Whatever you're looking for needs to be all on the same side of the equal sign, and everything else that don't have what you're looking for is on the other side. Here you already have one A term by itself. We want to get this one over to the other side, all right, to join its cousin. Here we go. We got to add it over. It's being subtracted. We're going to add it over. We're just using adding, subtracting, multiplying, dividing. Just using some manipulation. So here we have MA plus 4A equals this thing without an A. All right. Now what are we going to do? We got all our A terms together. We're looking for the A. What do we need to do? Tell it.
Divide by M.
can't divide by m, because if we do that, then we're going to be creating some fractions, but that still won't get us the a. Think of something else.
Joshua says divide.
Divide by what? What are we going to divide by, Joshua? Yep, okay, not the m. Okay, so what are we looking for again? Remember, you got to keep your eye on the prize now.
Do we divide by 4?
No, for the same reason we can't divide by the m. Okay, let me ask you this question. If you didn't have that equals z there, and you just had ma plus 4a, and you wanted to solve or get the a, how would you do it?
Subtract by MA? I don't.
No, what are we doing 10?
Greatest common factor.
Oh, there you go. Hey. Okay, so those terms have what we're looking for in it, right? They have it in common. So we're going to use factoring to get it out. That's why we have to isolate those terms on one side of the equal sign, because we can then factor out what they have in common. So now we can factor out the a, because that's what we're looking for. Now, that's just like dividing it out, right? Because remember, factoring is just like dividing something out or something, right? That's why I said, when you said divide, that's why I said divide by what? You could divide the a out, and we call it factoring, okay? So we take the a out, and what are we going to be left with?
M plus 3a? 3.
No, if I take an a from here, I'll be left with what?
M plus 3?
No, m, and then plus, I take an a from here, I'll be left with, there you go, Joshua, m plus 4, right?
Oh, right.
All right, you can only be left with what you have now, okay? So you're only taking out the a, and the a is not related to the 4. These are two different terms. M is separated from the a, it's two different terms. 4 is separated from the a, that's two different terms. So when we remove the a, then we're left with m and a 4. Just like in 10, when we took out the x, we wasn't left with x minus 1 because we took away the x, right? We were left with the 2 because the 2 and the x was two separate things. Does that make sense? Yeah? Okay, so remember, don't put those things together. These are individual things. They just happen to be hanging out together. Is everybody all right? Okay. So equals z. All right, finishing it up, we still got to solve for a. What's our last step here? Now we can use the D word now.
You can divide the n plus 4.
There you go. So now we're going to divide out what we don't want. Now we don't want this stuff right here, right? So we divide out the m plus 4. This goes away and we're left with that a, which is what we're looking for. And then we have z all over m plus 4. Now, make note that if you solve this problem and you still have an a on both sides of your equal sign, did you solve for a? No. Okay, so if you're solving for a letter and you have it on both sides of your equal sign, you didn't solve for it. That answer is wrong. All right, so you'd have to stop, go back, start over again. Okay, and remember, you only have a select amount of steps. What did we do? we got all our terms together to have what we were looking for in this. So that was step 1. We factored out what we wanted because they had it in common. That's 2 steps. Divided by what we didn't want. That's the 3 steps. 3 steps to solve this problem. If it took you 5, 6, 7 steps, you'd have made some steps up. Then you need to go back and start over again, okay? They don't exist. You made them up. All right? Okay. Here we go. Number 12. 12 says simplify the complex fraction. So remember, complex fraction is just simply a fraction divided by a fraction, and they're putting it one on top of the other. If we had these fractions one divided by the other on the same level, we wouldn't call it complex, okay? But once we start stacking them on top of each other, then they want to change the name on us, make us think it's something different. It's nothing different, okay? They just want to call it something different to make us all anxious. Okay, don't let them do it to you. Here we go. It says x all over x squared minus 16. Okay, here we go. Number 12. X all over x squared minus 16 divided by, that's our big division line there. And then we have 1 over x minus 4. So we have one fraction divided by another fraction. How do we divide 2 fractions? What does the rule say to do?
Common denominator.
No, not a common denominator. That's usually when we're adding and subtracting. But what do we do when we're dividing fractions? It tells us to do something. Think about it.
Do you have to put like the top x over like, so it's like A over D, B over C, something like that?
You're kind of on the right track, but try not to think about changing the letters. Don't think so complex about it because it's a complex fraction. Go ahead. Don't play it horse. No, but think about it more simply. So the rule says when you're dividing 2 fractions, don't we keep, change, flip?
Oh, yeah.
Yep. Right? So don't think too deep about it. Remember, we just have that simple process where we change division to multiplication, but we got to keep the first fraction, change the division to multiplication, and then flip the second fraction. Okay? So here's our first fraction. The top one's always our first, right? Then we're going to change this. So here I am rewriting it now. I'm going to keep this just the way it is now. So you have x all over x squared minus 16. Now, feel free that if you see that you can go ahead and simplify something, go ahead and do it. Like if you can factor or something, do it. But I'm going to do it in the next step. Okay? Then I'm going to take my division line and change it to multiplication. And then my second fraction, I'm going to take the reciprocal of it, flip it over. So here you have x minus 4 all over 1. Is everybody all right with that? Right? So now division of 2 fractions is nothing but multiplying 2 fractions. Okay? Now, I see here, I have x squared minus 16. I can take and do something with this. I can simplify that, right? We can factor it. Remember, the aesthetics of the problem is going to help you. You know that there might be something that you could simplify or cancel. Okay, we can, after we factor this. You have x squared minus 16, that's our friend. And we know that that factors into what?
X plus 4, x minus 4.
There you go. Y'all are on it. X plus 4 and x minus 4. Okay? So now that we've keep, change, flipped, we factored, all right? Now we're ready to go ahead and we can get rid of some stuff. We can get rid of this x minus 4 here. All right, I don't think we can get rid of anything else, right? So our final answer, x on the top and on the bottom, x plus 4. Are we feeling all right about it? So complex isn't really complex. We just divide into fractions, okay? But remember, keep, change, flip. All right. Number 13, solve the system. Now remember, system of equations, we learned 3 different ways to solve a system. First way was graphing. Remember that? What was another way? We learned 2 other ways. One begin with an S. Come on, I know y'all remember. We did a good bit of these.
Then we have to solve for x and y differently.
We did. We learned some methods of how to solve for them. Do we remember what they're called?
Is the S word substitute?
There you go. All right. And then the other ones begin with the E, probably, or an A, depending on which author was, you know, how the author was feeling at the time. We talked about both ways. Some people called it where we eliminated something, right? And some people said the addition method because we were adding them together, right? So elimination and addition method, same method, right? It just depends on what, you know, they was talking about in the book. So we learned graphing, elimination or addition method, and we use substitution. So if they give you a system and ask you to solve it, it's up to you, whatever makes you feel comfortable, how to do it. Now, this particular system, they actually helped us out. They took this first equation and they already have it solved for y. Do you see that? Y equals 3x. This is already set up for substitution. So we can just use substitution. But now remember, if you're really impartial, if you really love the elimination method, remember it has to be lined up in standard form. So x plus y equals constant, so that you can line up your like terms and then you can eliminate one of your variables. But since it's already ready for substitution, I'm going to use substitution. Okay. Substitution tells me, since I know that y equals 3x, I'm going to take and I'm going to substitute, right, my first equation into my second equation, right? So wherever I see a y, I'm going to put this 3x. So we have x plus 3x equals 4. Now I've created an equation that only has x values. I'm going to now solve for x. So x plus 3x is 4x equals 4. So I see that x equals 1. I just found the first piece of my ordered pair. So remember, the solution to an system of equations is an ordered pair. So if you can find one letter, then you know that the other letter can be found. So we found an x, that means that there's a y out there that we can find. So since x equals 1, I can now take that information and plug it into any one of these original problems, and I can find out what my y value is. So I'm going to plug it in right here. So I see that y equals 3 times 1. So y equals 3. So my ordered pair is 1, 3. Don't forget your parentheses makes the ordered pair. Now, They may ask you to put it in ordered pair form. Make sure you put the parentheses. If they may ask you to just tell what the x value is of the solution, or just the y value of the solution. Make sure you are reading the directions and giving them what they want. All right? Is everybody good with it? Okay. All right, we're ready to move on. Here we are, 14. Now 14 is just a look-see-tell. Look-see-tell means they want to give you a picture and then they want you to tell what the solution is. So it says, how many solutions do we see? How many solutions does this system have? We know it's a system because we have two lines being grafted. We have L1, that's line 1, and L2 is line 2. How many solutions does this system have? You say 3 solutions? Okay. Now remember, you have just this one line and the second line. So look carefully now. Now remember, in our whole entire life of solutions, we only have 3 different types, right? We have 1, none, and a whole heck of a lot, right? So out of those 3, which one do you think this has? 1, none, or many? Okay, Joshua says 1. Does everybody agree? Do we think something else? Ayla, what do you think now?
I'm so sorry. I was distracted at the time that you asked the question. Can you please repeat that? I apologize.
How many solutions do you think it has? It can't have 3 because we only have 3 different types of solutions. We only have 1, none, and many. So out of those 3 choices, which one do you think, by looking at the picture?
By looking at the picture, I say many.
You say many?
Mm-hmm.
Okay, so if it's many, then that picture should look like one line sitting on top of the other line. It would be the exact same line, right? Because that means that it's touching each and every point on that line. Does that make sense? That's not happening on this picture. You see that you have 2 lines crossing. So where do they touch? How many times do they touch?
I see what you're saying. So it would be 1.
It would be 1.
Okay.
Okay. The definition says where the lines intersect, and they only intersect here one place. Okay.
Okay. Yeah, I read that question wrong, so I'm glad that you clarified that.
Okay.
Thank you.
All right. All right. So, and then if it was none, that means it would be like 2 parallel lines running right next to each other, right? They'll never touch. So that would be no solution. Right? So they may give you one of those pictures. Here we get this picture. Okay? So make sure we know the difference between the 3 different pictures representing our 3 possible solutions. Okay? So 1 is all we got there. Now let's hit up number 15 and see what happens here. So here's 14. We have 1 solution. All right, number 15 says, evaluate, and they gave us these two values that they want us to multiply together. So watch it now here. We're evaluating a raised to the 3/4 times, and you notice they didn't give us a time sign, but I'm going to put the time sign in there because it makes me feel good in my spirit. So in the test, when you see it, and they may not give you one, you put it on your paper when you're working it out. So you have a raised to the 5/4. Now, this particular problem, it's really nice that they gave us these fractions and they both have the same denominator. Do you see that? That's just so nice of them. But what's important to remember about this particular problem is the rule. The rule says when we're multiplying and the bases are the same, what are we going to do to the exponents? That's what the rule says. And the rule says, what are we going to do to them?
Subtract the exponents.
Not subtract. You're kind of close, though. What's the opposite of subtraction?
Adding.
Right?
I had it the wrong way.
All right. So when we're multiplying and the bases are the same, we're going to add. But when we're dividing, that's when we subtract. So remember, addition is synonymous with multiplication is synonymous with addition. Division synonymous with subtraction. Is everybody okay? All right. So watch that out now. We're going to still keep the same base. We've got to add the exponents. So when they give us these fractions, we're not going to be freaking out about it because one, we got a calculator. But two, they helped us out because they gave us the same denominator. So we don't even need a calculator for this thing right here. We're going to whip you wood right now. So we have A, it's our base. And then we have 3/4. I'm going to put a plus sign right here because I can. And now we're going to add these things up. So we get our 4 is our common denominator. And then 3 plus 5 gives me 8. Can I simplify this fraction? What do I get?
I got a squared.
Okay, this simplifies to 2. So my final result here is just simply a squared. Just that simple, right? So you see some fractions in there. You just got to remember the rule, all right? The rules, when you're multiplying the bases are the same, you're going to add the exponents, and if those exponents are fractions, you can put it in your calculator and let the calculator do it, or you can go ahead and just add across. If they give you the same common denominator, that's great. If they give you different denominators, you know you got to find the common one and work it accordingly. Again, you got a calculator, you can just put it in there and let the calculator do it. And in class, remember, we showed practice in our calculator how our calculator can simplify our fraction and write it as a reduced fraction for us, okay? Remember, if you don't remember how to do that in your calculator, you can see me in office hours or just Google your calculator and the YouTube video will pop up to show you how to use your calculator and write your funky decimals as reduced fractions, okay?
Or you can sign up for tutoring and a tutor will work with you too.
That is very true. All right, and I put that link in our Canvas shell, right? That page for the Learning Commons, all right? So you can sign up through the system, okay? All right, so there's our number 15. We're working through it. Here we are, moving to our next page. All right, number 16. Graph the solution to this system of linear inequalities. So we have linear inequalities. How do we know? We have our inequality symbols in there. And it's a system because we have 2 of them. So they want us to graph the solution. Now they may just want you to graph one of these linear inequalities. Look at this, it might be a multiple choice selection on the test. We still need to remember what these symbols are and how they correspond on this graph. So here we are looking at, we have x is greater than or equal to 2. And then we have y is less than 3x plus 1. So we're graphing, all right? Think about what's happening now. Remember that we're on an X and Y axis. Remember we use open and closed circles to represent stuff, yes. But when we're dealing with our inequality symbols on the X and Y axis, we use certain types of lines to represent these things. Now, this is going to help us tremendously when we're on the test, because if they ask us to pick the graph that corresponds, then we can rule out a lot of stuff. All right, here we are. I'm going to number, since we're dealing with the system, so we can keep our stuff straight. So our first line here is X is greater than or equal to 2. Does everybody remember what kind of line that is? X is greater than or equal to 2. That's a specific type of line that we looked at. Do we remember? Ooh, I know somebody remembers out there. Make me proud.
I'm sorry, could you repeat the question?
What kind of line is X is greater than or equal to 2? What is that line going to look like?
Dotted?
It's dotted. You think it's dotted? First of all, tell me what kind of line. Is it going to be?
It's solid. It's solid, and then you highlight the other side, right?
Okay, you say it's solid. Is it going to be an increasing line, a decreasing line, a horizontal line, or a vertical line?
Vertical.
How do we know it's going to be vertical?
Because the only one that we have is the X. We don't have any Y's.
Okay, so right there we know it's going to be vertical because of that. So it's a vertical line going through the number 2. All right, so here's my number 2. It's going to be vertical, and because it is a greater than or equal to, it's going to be a solid line. Let me see if I try to get it straight. Here we go. Ooh, sort of, kind of. There it is, sort of, kind of. And I'm going to label this as my line 1. All right, that's going to help me shade and all that stuff I got to do, okay, later on. All right, now let me graph the second line, which is y is less than 3x plus 1. So now, here it is. Before I get it going, I know for sure, because this was a solid line, I know this one's going to be that broken line now, right? And I know for sure that this line is going to go through this number. But is it going to be increasing or decreasing? Horizontal or vertical?
It's going to be an increasing line because of the fact we have a positive 3 next to the X.
Wonderful. All right, so that's my check now. I know now that I'm going to have an increasing line going through a positive 1, and that's how my check is. So when I'm getting the graph in it, or you're looking for at the multiple choice selections, then you know for sure you're looking at the right thing. So here I am graphing at positive 1, my first point, and my slope tells me to go up 3, 1, 2, 3, and over 1, right there. Well, it's actually about right there. And then this is going to be a broken line. I'm going to go down 1, 2, 3, right there. This is my supporting dot. Okay, now here I am. Boop, boop, boop. Break it on up, break it on up. And there's my broken dashed line, line number 2. All right. So I got my 2 lines all drawn. Here we have a solid line, here we have a broken line. Now I need to complete it by shading each line, just like you were saying before. Now, here we are, my first line. Here it is. Remember, vertical line doesn't have a top or a bottom, but we have a left and a right, or a positive side and a negative side. Am I going to shade the left or the right?
The right.
The right, because X is greater than or equal to, so I'm going to shade over here. So I'm just going to just put bloop, just some little light lines. Let's see what's going to happen here. All right. Okay. Now, my second line here, am I going to shade the top of the line or the bottom of the line?
Bottom, because it's less than.
Okay, it's less than, so I'm going to shade the bottom of the line. Now remember, we're looking for where the shadings come together. Where they overlap, that's going to represent our answer. That is considered our AND solution, where they share the shadings. So when we look at our second line here, and I shade the bottom half of that line, I see that they start touching my first shadings right here. So right here at this part on down. So I'm going to make some cross marks here. So I can tell that this area right here is where my solution to this system is. Okay? So no matter what ordered pair we pick and plug into the system, it's going to work for both or be true for both of these inequalities. It does not cross into this little area right up there. Okay? It's right below the dotted line. Is everybody okay? So that is my answer area right there. Any questions about it? Now again, you might just get one of these where they just want you to graph one linear inequality instead of a system. But at least we now are refreshed on how to graph a linear inequality. Make sure you pay attention to what you're shading, what symbols they're giving you, and the lines that they're giving you. Very important. All right. And this was what number?
16.
All right, here we are with 17. Okay, 17 says solve. So now they're giving you an equal sign. So now here we are, we can illegally put that equal sign in there because they say solve. They give it to you. They give us 2x squared plus 5x minus 3 equals 0. And they want us to solve. What they gave us was a trinomial. Right there, we know we got to factor it in order to solve it. Now remember, we also learned in our last section the quadratic formula. If you feel like you want to just go ahead and use the quadratic formula to solve it, feel free. But go ahead, try to factor it. You might be able to do it. If in the directions they tell you right off to use the quadratic formula to solve, you got to use the quadratic formula. You will not be able to factor it, okay? But here they just said solve, so I think we can go on and try it. Let's see. Asking ourselves the questions. Do they have anything in common between all three parts that we can factor out? No. Here's my supplemental questions. Is the first term perfect? No. That 2 stops it. Now I'm regularly going old school now. Old regular factoring. I'm going to start with what I know for sure. I know for sure about this 2x squared. I know that the factors of 2 are 1 and 2. I can't go wrong with that. So I know I'm going to have a 2x somewhere and an x. Doesn't matter where I put it. I just know I'm going to have it. Then I'm going to look at the factors of my last term. I have a 3. Can't go wrong with the factors of 3. It's a 1 and a 3. I just need to figure out where I got to put it. I have a 5 in the middle. Don't guess about it. Just plug it in and then you can check it. See what happens. I'm going to try putting it here and here. What do you think about it? You think it's going to work? Remember, my lead term is a 2, right? Has a number there. That means you need to at least do the inner and outer check of your FOIL to see if it comes out. Again, feel free to do the whole entire FOIL if that makes you feel comfortable. but you at least need to do the inner and outer check to see if it gives you what you need. Let's check it. You notice I haven't put any signs in. I just want to see if I get the number and I'm going in the right direction, and then I can see if the signs will work. Here's my outer check. 2x times 3 will give me a 6x. My inner will give me a 1x. And if I subtract, I can get a 5x, which is what I have there. But will the signs make it work? I need a positive 5x. So my bigger number would be positive, right? That means my smaller number would be negative. I can get a positive 5. But can I get the negative 3 back? Here we go. Positive 6, negative 1. Gives me my positive 5. That looks good. And then negative 1 times a positive 3 is a negative 3. Looks like it checks out. It works. Do you feel all right about it? What if it didn't work? Remember, I would just switch them and try it again. That's why it's called trial and error. Don't think so hard about it. If it doesn't work, now you got to remember, you got to trust your check. That's why you got to check. So you got to trust it. If it's telling you it's not going to work with the signs, you got to flip those things around and try it again. Then your signs are going to work. Now the numbers are always going to look good sometimes, but those signs, if they're not working, that means you got to rearrange those numbers. And always just rearrange the last numbers, okay? And then try your check again and see if those signs are going to make it work. Any questions about the factoring part and the checking part before we get to the solve? All right, so here we are. Now we're ready to solve it. So we got our factor, 2x minus 1, and then x plus 3. Now we're trying to solve for our x's. We're going to set these equal to 0 using our zero product principle. So we have 2x minus 1 equals 0, and then x plus 3 equals 0. So our two values for our x, we have x equals 1/2 and x equals negative 3. And those are our two values. All right. Always, again, I can't stress it enough. Check your trinomial factoring. Number 18, it says find the least common denominator. Now, sometimes they just ask you to do this, but remember, when do we need a common denominator? When they ask us to find a common denominator, when we're solving, when we're adding, subtracting, okay? We do not need a common denominator when we are multiplying or dividing, all right? We do not need it there. But when we're adding, subtracting, solving, or when they just ask us to find the least common denominator, that's when we need it. All right, let's find it. We have 18. And they gave us this problem here. We have 3 over 2x minus 2 plus x all over x squared minus 1. Again, in order to find the least common denominator, we need to factor all of our denominators first. So this first denominator has a 2 in common. Always ask that basic question, do they have anything in common? We have a 2. We're going to take it out and we're going to be left with x minus 1. Our second denominator is x squared minus 1. They don't have anything in common, but we see that it fits the criteria for the difference of two squares. And this can factor into our friend x plus 1, x minus 1. All right. Now remember our rule. To find our least common denominator, we're going to make our list. Write all the factors for your first denominator, no matter how many times they repeat. You have 2, and then you have x minus 1. That's from there. Then we're going to look at our second denominator, and we're going to see what's missing. And if there's anything missing, we got to add it to the list. Do we have an x plus 1? Nope. Put that on there. All right. Do we have an x minus 1 already? Yep, we already do. We don't have to write it. So our least common denominator, all right, or least common multiple, which is our denominator, would be 2 times x minus 1 times x plus 1. All right? It never changes, everybody. The only thing that changes is that our numbers and our letters, but the process never changes. You still have to factor your denominators and then write all the factors. I don't care how many times it repeats. You write all the factors for your first term. Then you look at all your other terms, all your other denominators, and you see what you're missing. If you already have at least one of those things on there, you don't have to write it. But if you have more than that, you got to write those additional terms. So whatever you're missing, you got to replace it on there. And then combine what you can. Here we can't combine anything. Remember, we're not distributing. Our least common denominator, 2 times x plus 1 times x minus 1. There it is. All right. Number 19. They want us to write the slope-intercept form of the line passing through the points -1, 4 and 2, -10. So here's number 19. They want us to write the equation of the line passing through these points. So -1, 4 and 2, -10. Now, they gave us 2 ordered pairs. In order to write an equation of a line, we know that we need 2 pieces of information. We need a slope, and what's the other piece?
The y-intercept.
The y-intercept. Here, they gave us 2 ordered pairs to work with. What are we missing?
Missing the slope.
We're definitely missing the slope. Do we have a y-intercept here? Did they give us one?
We need to use m equals y2 minus y1 over x2 minus x1, right?
Okay, that's going to give us the slope, right? So first we got to find the slope. All right, so we have our slope formula equals, plugging in, making sure we watch our signs now. We're going to do our sign transition as we plug in. So y sub 2, which would be -10, right? Minus y sub 1, which is 4, all over 2, and then watch this now, minus x sub 1, but remember it's a -1 there, so we have a sign change right there, plus 1. Is everybody okay with that plug-in? So right here we had a sign conversion. When we simplify it, we get -14 all over 3. And we can't simplify that, so we get -14 over 3. Is everybody all right with that slope? Okay, so we have a slope, but we don't have a y-intercept. What's the next formula we need to use to write our equation? There's a couple of ways you can go. So which way you want to go?
Can't you do the point slope formula?
We got a point for sure, and we just found the slope, so we can use the point slope formula, right? Because then when we finish solving it, we're going to be right there at the answer, right? Some people might have used the slope-intercept form and went ahead and plugged it in. But remember, you got to take that information you find and plug it back into the slope-intercept form to write your equation. But here we are. Let's use the point slope form. All right, it's there in the chat for us. So we have, which point you want to use, the first one or the second one? The first one looks a little more friendlier, I think. So let's use that one. So we have our slope and we have our point. So here we are, we have y equals. I'm gonna go ahead and use the supplemental version where we solve it for y already. So we have our m, we just found, -14/3 times, remember our stationary x, and then our x sub 1, all right, which is, again, here's a sign conversion, all right, and then plus y sub 1, 4. So there's our plug-in. All right, now we're ready to take it to the next step. So now we got to distribute and combine like terms. So here we have y equals -14/3 times x plus 1. Oh, sorry. Thinking fast. All right. Where? Okay, so we have -14/3x. Then we distribute here, you get -14/3. Then we got to bring down our 4. Now remember, here we're using our calculator either by putting our -14/3 plus 4 in our calculator to find out, do our calculations. If we're changing our 4 into a fraction, that helps us. We're doing that. Remember, we went over how to do that in class. Take our whole number, multiply it by our denominator, and then put it back over the denominator. So 4 times 3 is 12. So 12/3. That gives us the same common denominator, and then we can do our combining like terms, or however you want to do it. Remember, old school, new school, or whatever school, right? Remember, we just know some school. Okay, so then our final result is y equals -14/3x. And then when we get -14 plus 12 gives us a -2/3. So our equation in slope-intercept form is y equals -14/3x minus 2/3. Make sure you use your formatting tools on the test so you can make sure you put it in the right order. Make sure it looks correct so that they're cut down on your syntax errors. Right? Any questions about that? Okay. 20. Write the equation of a horizontal line passing through the point 7, -3. What's the equation of a horizontal line again?
Whatever y is equal to.
Okay, and what is it equal to here?
-3.
Okay, so our answer for number 20, y equals -3. Any questions about that? Our key word, horizontal. And we just have to remember the equation of a horizontal line is y equals, and whatever y they give us. So y equals -3, all right? What if I asked you to write the equation of a vertical line going through that same point? What would your answer be? What do you think? If you're writing a vertical line.
So
Nobody?
just x equals
X equals what?
whatever the x is in the
Which
integer they
is,
give us, or the ordered pair they give us.
what is it?
It'd be 7 for a vertical.
Okay, so X equals 7.
Right. Sorry, I thought you were just asking in general what it is.
No, for this particular problem. So X equals 7. Do you see how it works? So whatever they're asking you, right, you just have to remember what the equation of that line looks like and what it is. So horizontal and vertical are friends. Just remember what axis it goes through, and you'll always remember what the equation of the line looks like. All right? Okay, number 21. We're dividing using our scientific notation. So 21 says divide 6.2 times 10 to the negative 15. So 6.2 times 10 to the negative 15 all over 2 times 10 to the negative 3. Again, our exponential rules come into play here. Again, you can put this in your calculator, but the beauty of this whole thing is that you don't have to use the calculator when you're dividing with scientific notation. How many times does 2 go into 6.2?
3.1.
Mm-hmm. So 3.1, and then you have your standard time sign, your standard base 10, and then here comes our rules. We said it earlier now. When we're dividing and the bases are the same, what are we going to do to the exponents? We remember? Okay, do we remember? Come on.
You subtract the exponents.
Okay, now you see how they're trying to trick us when we have negative exponents for both? Just be careful. Put it in your calculator. Negative 15 minus a negative 3. Or how I like to do it is write it out. So you have negative 15 minus a negative 3 is the same as negative 15 plus 3. And that gives us a negative 12. So our answer, 3.1 times 10 to the negative 12. Now remember, scientific notation has to have the 4 parts: the decimal number, the time sign, the base 10, and the exponent. Anything else can't be your answer. So if it's missing the time sign or it's missing a base 10, it can't be your answer. All right, so be careful with that. Number 22 says add the square root of 50 plus the square root of 18. So the square root of 50 plus the square root of 18. So 22. We're going to add the square root of 50 plus the square root of 18. We can't add these things yet because remember, in order to add or subtract radicals, they have to have exactly the same square root sign, they do, and they have to have the exact same stuff underneath in order for us to add the coefficients of these radicals. So we have to use our simplification knowledge to break down these radicals and see if we can get the same stuff left underneath. So the square root of 50. Now, some of our calculators will do this for us. So if we put the square root of 50 in our calculator and press enter, some of our calculators will actually simplify the radical for us. That's great. A lot of our calculators will not. So we have to, again, be familiar with what our perfect roots are. So here we have 50. I know that a perfect square root in the factors of 50 that I can break out here. Does anybody know what's the highest perfect square root that we can bring out of the factors of 50?
25.
Beautiful. So we have 25 times what number?
2.
There you go. And then plus, over here, what's the factors of 18 we're going to use?
4.
Not 4.
9 and 2, sorry.
There you go. 9 times 2. So now we know we're on the right track because we're going to have them 2's left over, and then we're going to be able to add these things together. Here we are, the square root of 25 is 5. So we're going to leave the 2 under there, plus the square root of 9 is 3, leaving the 2. Now we're in a position where we can go ahead and add these two things together. And so 5 square root of 2 plus 3 square root of 2 gives us 8 square roots of 2. So we were able to add. All right. How are we feeling about the test so far? Do you feel strong or good about the test? You feel like you'll be all right with it?
I feel better now that I've done a few more of the questions.
Okay, good, good. All right.
I feel good up until now, but this is also as much as we've learned before coronavirus.
Okay, so it's coming.
So,
is it coming back?
It's coming back, but now we're into the part where we start breaching, where we had to teach ourselves online, kind of.
Okay, so being able to remember that stuff. So bringing back and then the new stuff. Did the videos help?
Yes.
A lot, yeah.
The videos of the lessons?
Yes, I helped out a lot.
That's great. Good. All right. So now we're almost finished with the first part. I think we could squeeze it all in. Okay, so we're dividing. Again, we're factoring and we know how to divide those fractions now. So we're going to keep, change, flip now, right? So number 23, go to a new page, says we're going to divide. They don't call it complex because they're not one on top of the other, but side by side, it's just regular old division. Isn't that something? So 23, they're asking us to divide. So we have x squared plus 2x plus 1 all over x minus 2 divided by x plus 1 all over 2x minus 4. All right, so remember, keeping, changing, and flipping. So when you know the pattern, again, you can go ahead and start factoring if you can see it, and then just make sure you get the flip in there and the change. So here we see at this top, we got a trinomial. I'm gonna go ahead and start factoring. Nothing in common between all three parts. I'm gonna ask my supplemental questions now. Is the first term perfect? Yes. Last term perfect? All the time, 1 is always perfect. Can the middle be broken up into 2 equal parts? Yes. That means this is a perfect square trinomial. I know for sure it's going to be factored perfectly into the exact 2 of the exact same binomials. So we have x plus 1 and x plus 1. So we know x squared breaks up into x and x. 1 breaks up into 1 and 1. Since my middle term is positive, both of them are going to be positive. It's perfect, right? I don't even need to check it with my FOIL. I know it's going to be perfect because it's a perfect square trinomial. All right. On the bottom, I can't do anything. Didn't have anything in common, nothing to factor, but just rewrite. So x minus 2. I'm going to change to multiplication. Now I'm going to flip. So my denominator here comes to the top. When I look at it, 2x minus 4, I see they got a 2 in common. I'm going to go ahead and take it out. And that's going to leave me with x minus 2. And then the numerator has nothing that I can do with it, but just rewrite it, x plus 1. Okay? Now, can I get rid of some stuff? All right, I can get rid of this x minus 2. I see that. And I could get rid of x plus 1s. And that's it. So what do I have left? Everything is on the top. So I'm going to bring my number forward because that's where we usually see it. So we have 2 times x plus 1. And there is my final result for that one. Remember, don't distribute anything, okay? Your answer has to be in this most simplified, factored form. Okay. Any questions? Okay. 24. Use the quadratic formula to solve this problem. Now you see how in the directions it says use the quadratic formula. That means that you can't factor it. So don't waste your time on the test trying to factor it. You can't. So here we have 24. And our problem is 3x squared minus 2x. 3x squared minus 2x plus 1 equals 0. All right, remembering that with the quadratic formula, it relates to the quadratic equation, has to be set equal to 0. Your leading term needs to be positive. So make sure it's there, and it is. Our quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Remember, it's always good to label so you can plug in the right thing. So a equals 3, b equals negative 2, c equals 1. You do not have letters in your formula. You have A, B, and C. They should correspond to the coefficients to your x squared, coefficient to your x, and your constant is your C. So when you plug into your formula, all right, you should only have numbers in there. You shouldn't have any x's up in there or anything. If you do, you done plug some stuff in wrong. All right? Now, have we all done this problem already? Let's try working it real quick on our own. I want to see how we do with our plug-in. This is going to be really important. All right? During that dry, let's do that rough plug-in. Make sure we get the transition of our signs. Make sure we're using our parentheses with the plug-in. It's so important right here because we have some tedious parts in here where we have to make sure that we keep our signs straight and that we evaluate this stuff correctly. So let's take just about 1 or 2 minutes to see if we can plug it in on our own into the formula and evaluate it. And then we're going to come back out and then double check it. All right. Okay, we should be about there. Okay. Let's see if that works. All right. So technically we have 9 minutes left possibly before it closes out. I just extended the time. I don't know if it will extend while we're in the midst. Let's hope it does. If it does not, just stay next to your email and I'll send you another link to join and then we'll continue, okay? All right. I did want to finish at least this first part. All right. Go ahead and set it up, Vera, just in case it doesn't extend itself.
I want to see if it'll copy right into here.
Okay. All right. So here's our setup now. We should have already plugged in your rough plug-in. Here it is. X equals. Remember again now, using your parentheses. So you have this negative b is a lead off right here, but my b term is negative. So we have this negative. Here's my parentheses with my -2 going in. All right, plus or minus. The square root of, here's my b, again, parentheses, I'm plugging in a -2, and then I'm going to raise it to the second power, -4, times 3, times 1, okay, all over 2 times 3. That is my generic plug-in. Again, as you're plugging stuff in and you feel comfortable enough to go ahead and do the transitions while you're plugging it in, feel free. But make sure you watch this first lead off. And here's another crucial part right here where this b squared, that's really important right there. For some reason, we don't want to use parentheses and we just put the -2 squared by itself. And then when we put it in our calculator, it's going to give us a false answer because we're not putting it in correctly. All right, so now let's evaluate. Here we have negative times the negative is going to give us this +2, plus or minus the square root of. -2 squared is going to give us a +4. Then we have -4 times 3 times 1 is a -12 all over +6. Okay, taking it piece at a time now. Then we have x equals 2 plus or minus. Then we have 4 minus 12. Now right here, we know that we're going to have a negative number left underneath this radical. Right there, you know something is coming up. What's coming out? An imaginary number. Okay, so we have the square root of negative what? What do we get?
A -8i.
Okay, it's not a -8i, but it's a -8. Don't say the I yet because you haven't evaluated it yet. Okay, the I comes after you evaluate. Make sense? I don't want you to confuse it and then try to combine it and make a whole new answer. We call that wrong. Don't do that, okay? But you're on the right track there. Here we are with a square root of -8. Now we're ready to evaluate what's going on. So now underneath our radical, we got to clean it up. So we have x equals 2 plus or minus. We see that 8 is not perfect. So what I'm going to do is break it up with the factors to see what I can bring out. So the factors of 8 that have a perfect square root in it, did you use 4 times 2? I'm going to use that. We have 4 times 2 times the -1. You see how I put that as one of the factors? Because now I know what my definition, I can take the square root of that -1, and that's where that I is going to come from. So now here I go. And I'm going to bring it up here now. So we have x equals. So then we have 2 plus or minus. I'm taking the root of this stuff now. The square root of 4 is 2. The square root of the -1 is I. Scratch that off. And then what's left is the square root of 2 all over 6. Is everybody okay at this point? No questions right here? Good. Okay, thumbs up. Wonderful. So now, we're still not finished though, because we got to simplify our answer. Right here, make sure that when you bring that I out, if you have the I on the back end of your radical, that's fine. It's fine if you have it there. You just got to make sure that you don't put it underneath the radical. So when you put your square root of 2, you got to cursor out of it and put your I behind the radical. But if you put it underneath that radical, your answer is going to be wrong, okay? So I put it in front of the radical. That way I make sure it's not going to be underneath it. But if you want to put that I, have 2 square root of 2 and then the I on the back end, that's fine. Just make sure that it's not underneath the radical, okay? That is what's most important. Okay, so now I'm going to simplify it because I have a 2 here, a 2 here. I have a 6 in my denominator. I know I can simplify that. We can use factoring to do it. Or remember our golden rule of simplification. If you have 2 or more things sharing the same denominator, that means that we got to split the denominator between the 2, and then we can simplify. Now it's going to work out pretty nicely here. So let's try to see if we can keep it all as one whole thing. Right? Don't be splitting. Let's do some factoring to do it. Do you agree that they have a 2 in common up here? And we know that if we take that 2, it'll simplify with that 6, right? Okay, let's take out the 2 from the top. We can factor out the 2 from the top, and that's going to leave us a 1 plus or minus. Take the 2 from here. It's going to leave me a 1i. I won't write the 1, but I'll just leave the I there. Square root of 2 all over 6. All I did was factor out the 2 from the 2 terms they had in common. And then I'm going to cancel 1 time and I'm going to be done. So 2 goes into 6 3 times. So my final result, x equals 1 plus or minus I square root of 2, or 2 square root of 2i. Again, remember you could do that. All over 3. And what you'll do on the test, just like you did in the homework, you'll separate your answer with a comma.
Wait, where did the other 2 go again?
What 2? This 2 right here, this one?
Yeah.
I factored it out. These are 2 separate terms here. They have a 2 in common. I pulled it out in front, factored it out, and this is the 1.
Okay, I get you.
Okay? Any other questions or concerns about it? All right. You see how they sneak that factoring in there sometimes, right? Yeah, I told you, I tell you, it's there all the time. All right.
Okay, so it's 4 o'clock. Margolette, I sent you a link and a password just in case it starts to look wonky on us that we could share. But you want to just keep going then and see how long it lets you go?
Yeah, I extended it an hour.
Oh, okay.
So
we'll see what it does.
Yeah, let's see. It's 4:01 now and it hasn't cut us. So
yep.
That's the good that you can extend it while you're in the meeting. That's good.
That is good to know.
Yes, good enough. Okay. All right, let's go on to 25. So looking at 25 is a graph. It says, is this graph a function? So they give you, this is a multiple choice selection. They give you 4 pictures to look at. And then they ask you to tell which one is a function or which one is not a function. How do we tell if a graph is a function or not? We use some type of test to tell.
The vertical line test.
Beautiful, the vertical line test. So our graph that they gave us is a picture. Everybody's looking at their handout. We see that it's that V-shaped graph. Do we think that this is a function or not? Yes or no?
No.
We say no. Anybody else?
I think yes.
You say yes?
I think yes.
Okay. Now remember what a function means now. It means that when you look at your graph, you're going to take your vertical line. Now your vertical line is your pencil or your pen or whatever it is. And you're going to draw a vertical line or hold that pencil or pen right up against that picture. You're going to scan across it. And if that vertical line crosses that picture more than one time at any time, it is not a function, because that means that those x values repeat. And we know that if the x values repeat, it's not a function, right? Okay, so when we look at our picture here on 25, we see that this is clearly a function, all right? Because our x values here don't repeat, okay? There's no repeating x values. Can you all see my handout here? You can't see that, right? Because I stopped sharing my main screen. I'm just doing the whiteboard. That's right.
Can you do a split screen?
I don't know. I don't know if I can share.
You should be able to share too.
Let me see. I would have to stop sharing to share.
Mm-hmm. And then one of the options is to share 2 screens, and you pick which ones.
Yeah, it won't. Let me see. Maybe go to advanced. Portion of music one. No.
Maybe it was how it was originally set up different then.
Yeah. Oh. But if I share my screen, then I won't be able to write on the whiteboard. That's what it is. Yeah.
Okay.
Share. I have to work that sucker out too. Okay. So that's why everybody has their handout. That's good. So if you're looking, you'll see the picture that they gave looks something like this. All right. Okay. So if I'm putting my vertical line through it, here's my vertical line. It only crosses once right there, right? If I'm moving across my picture and here's my vertical line here, it only crosses one time. If I put my vertical line here, it only crosses one time. If I put it right here, it only crosses one time. Do we see what's happening? So because it only crosses one time at one particular, at any interval, this is a function. So yes, it is a function. If this was a circle, for instance, and I put a vertical line through, you see it crosses here and here at the same time. That means that those x values are shared. They're the same x value. You can't have repeating x values. So this would be a no. Does everybody see the difference? Any questions? Okay. All right. So our answer is yes, this is a function. All right. All right. Number 26. It says solve and express the interval in interval form. And we are solving a compound inequality being held together by the word or. Okay, so here we are remembering what and or means. Very important. So here is, I'll put 26 here and then I'll move to the next page. They're asking us, and they really helped us out here. They did x is greater than or equal to 7. or x plus 2 is less than 12. Okay? They want us to solve this compound inequality. Do we remember what OR means?
Union.
Okay, the union, good. So when we're solving a compound inequality, first things first, we got to solve for our x's. And this first one here, they already solved for x. So you just say, oh, thank you. You keep on moving. All right. The second one here, we got to solve for x. It only takes one movement to do it. We got to subtract the 2 over. And so we get x is less than what number?
10.
Mm-hmm. Okay. So now we have our x values going. We've refreshed ourselves on what OR means, and we know that means the union. And in lay terms, that means all together. Okay, now what are we going to do next? We done finished solving. What do we got to do? They want us to write it in interval form, our final answer. How are we going to find our answer?
You graph it.
Graph it. We got to graph it on a real number line. You can't just look at these things unless you're picturing it on a real number line. You can possibly do it in your head. And that's great. But if you can't, you got to put it on the real number line so that you can see what you're looking at. So here's my number line. Remember, it doesn't have to be no really, really big line. And you only need 2 numbers on it. We need a 7 and we need a 10. Okay, what symbols are you using? Are you using the circles or are you using parentheses and brackets? Which one?
I use circles. That's what I was always taught in high school.
Okay, circles. Here we go. So graphing our x's greater than or equal to 7. What kind of circle are we getting there?
Filled in.
Okay, close shading to the left or to the right?
Right.
Okay, here's a closed circle, and I'm going to shade the top of the line all the way to the right. Okay, there it is, right there. Okay, what kind of circle do we need on the 10?
Ten will be an open circle.
Shading where?
Left.
Oh, okay. So here's an open circle. Shading all the way, I'm shading the bottom of the line, all the way to the end of the line. Okay, to the left here. Okay, there's my graph. So we finished graphing. Now we need an answer in interval notation. What does your answer look like? Give me the symbol first that represents my interval answer.
It's parenthesis, negative infinity, bracket 7, union, parenthesis 10, parenthesis infinity.
Not quite. I do agree how you started off with the parenthesis and the negative infinity.
Parentheses, negative infinity, comma, infinity, parentheses.
Okay, I agree with that. Do you see how that can be our answer in interval form?
Yes.
Okay, because union means all together. So everything that's shaded is going to be in our interval, right? And you see that there are no gaps. So how you represented your answer indicated that there was a gap somewhere in between our shadings, and there is no gap. So our shadings,
Sorry, we only do union on OR problems, right? It doesn't happen on AND problems.
That is correct.
If there's a gap on and problems, then it's like no solution, right?
That is correct. But just because you have an or problem doesn't mean that your answer will always have a U in between. Do you see that?
So if it was X is less than 7 and X is greater than 10, where the shadings would be going in opposite directions, that would be a union?
It would have a union sign. You'd have an interval here, a U in the middle, and an interval there. Yes.
Right, but because they're actually crossing each other, then there's no union. It's just one interval.
That's correct.
Okay, thank you.
Mm-hmm. That's why it's so important to graph it so you can see what's actually being shaded. And you'll see that there's no gaps whatsoever. Now that gap can be really big or it can be really tiny. If there's even a little tiny something, then you have a U. But there is nothing being gapped there. Every number is covered, so there you should have one interval, okay? That represents what's happening. And that those shadings are covering. And it just so happens to cover from negative infinity to positive infinity. Any other questions about that and shading or what have you? Okay, good. All right, let's go to the next page. All right, 27. This will end the first part. And then for the second part, I'm just going to do a spit spot on that second part and pick up some problems that we did not do on the first part, okay? Okay, so number 27 says, is this a function? They give us a set of ordered pairs. And then they ask us to tell the domain and range of those ordered pairs. So 27. First question now, on the test, this might be 2 questions. It might be 3 questions. It might be 1 question, okay? So this, I'm just covering all of them so that we can know how to answer whatever they ask you. You'll know how to answer it, okay? So here we are. Again, talking about function, we're still talking about domain and range, but in the context of giving a set of ordered pairs. So they gave us a set, 27, and they ask, is it a function? Is it a function? Do we think so? Yes or no?
No.
No.
And we say no because?
There's 2 repeating Y's.
The domain repeats, yeah, multiple times.
Okay, because he just said the Y's repeat, but do we care about the Y's?
Excuse me, I meant the X, not the Y.
I go, okay, cool. Because the Y's here, they do repeat now, but we don't care about those Y's. That's good. But the X's do repeat here. So remember, if they ask you to explain, then you might want to say which number repeats. So just follow along. You could just follow what they're asking and stuff. So here, the answer would be no, because the 2's repeat. Or you could say the domain repeats or the X's repeat is fine. All right. Now they're asking us for the domain. All right, give me the domains. And I'm going to put them in my little squiggly brackets because we're actually pulling these things out and making a set of these things. So they should go in set brackets. So the sets of my domains would consist of what numbers? Which numbers? Come on, I want to finish up stuff. Y'all got to work with me. Okay, do we see what we're looking at?
So the domain is going to be -3, 2, 3.
Okay,
And the
so
range?
-2, I mean, -3, 2,
2 and 3.
and 3. And we don't have to write the 2 again because we already have it one time. All right. And then the range would be what numbers?
1, 5, and 7.
Okay, we say 1, 5, and 7. Again, we don't have to rewrite the 7 because it repeats. Is everybody all right? We're just pulling out the X values for the domain and the Y values for the range. That's it. All right. So there we are with the first part of our review, which should be pretty good there for us. For part 2, I want to look at
9 would be good. 9 would be good.
Yes, I'm going to do that one. All right. We are going to look at number 1. Find the slope. All right. So we're finding the slope of the line given this equation. So he wants to find the slope. So here we are with part 2. Okay. So number 1, find the slope. They gave us an equation. What form does it have to be in order for us to get the slope out again?
Y-intercept.
Okay, the y-intercept form. All right, putting it in that form. All right. Okay. All right. We should have it. We have 5x plus 3y equals 15. And putting it into slope-intercept form, we got to solve for y first. So we got to subtract the 5x over. You should have 3y equals -5x plus 15. Divide by 3, all the parts. So we have y equals -5/3 x plus 3 goes into 15. Always simplify your fractions. 5 times. All right, so we put it into slope-intercept form. What is my slope? So my m equals what?
-5/3.
Okay, so -5/3. All right, so if they give you this, make sure you just pay attention to your solving, pay attention to your signs when you're moving across your inequality, your equal sign, okay? And then picking the right part. So we know that this is our y-intercept, but they want the slope. Make sure you give them the right part. All right. Okay, let's move down to number 9. Put that special request in there. Number 9 says, the hypotenuse of a right triangle is 13 centimeters. One leg is 12 centimeters. Find the length of the other leg. Okay, so here they're asking you to use a certain formula. What formula do they want us to use? They gave us some hints in the write-up. It says the hypotenuse of a right triangle is 13 centimeters. Right there, we should know what they're talking about. What formula?
I'm not sure about that one.
Okay. Well, we're talking about a triangle, and specifically a right triangle. So when they're talking about a right triangle, we should be talking about the Pythagorean theorem. Okay, Pythagorean theorem. That is a squared plus b squared equals c squared. Is it coming back to us?
Yes.
Okay, so we just learned that in chapter 7. All right, so a squared plus b squared equals c squared. And they told us that the hypotenuse of the right triangle is 13. Which letter represents the hypotenuse?
I'm going to go with C.
Mm-hmm. All right, so the hypotenuse is always the longest side of the right triangle. All right, always remember that. So hypotenuse, C, 13, that's what they gave us here. And then it says one leg is 12. So here's the one leg, there's the other leg. It doesn't matter which leg you make the 12, all right? So I'm gonna go with this one right here. It doesn't matter. What matters is that we gotta make that 13, that hypotenuse, okay? So now I'm gonna plug it in because I gotta find the length of this other leg. So I have 12 squared plus b squared equals 13 squared. And now I got to evaluate it. What's 12 squared? 144 plus b squared equals 13 squared gives us what? Making sure we're working.
And awake.
Mm-hmm.
169.
Mm-hmm. So we get 169, and then we got to solve for our b squared. So we got to subtract the 144 from it, and we get what?
$25.
Thank you. And then we got to solve for b now. We already know what b squared equals, but we got to solve for b. So how are we going to do that?
Square root.
There you go. Using that square root property. So now we have b equals, the square root of 25 is, we should know that one off the top of our heads, right?
5.
Mm-hmm. And because we're dealing with measurement, we're only dealing with the positive aspect of our formula. So it's a plus or minus 5, but we're only going to recognize the positive here. So positive 5, and we're talking about centimeters, right? So 5 centimeters. And there's our answer. Okay. So look for those keywords. Hypotenuse, right triangle. You know you're dealing with a squared plus b squared equals c squared. Okay. Yep. All right, here we are. Looking at 10. Number 10 says solve. And it is a square root equation. So it says x equals the square root of 5x plus 14. So Here's a problem that has a square root in it. Now remember, we've dealt with a lot of problems that has barriers in it. This is just another barrier that we learned about. So we've learned how to deal with fractions, decimals, right? Parentheses. Here's another house, a radical. Okay, how are we going to get rid of it? Because what we want is underneath. So how are we going to get rid of this root? Now, we just did something similar in our previous problem, but how are we going to get rid of this root right here? What do? Go with your first thought. What do you think?
You square it?
You square it. How do you think why did you think you would square it? Why didn't you cube it or raise it to the fifth root? Why didn't you do that?
That's just from what I remember during the lessons. It was if you square it, it'll get rid of the radical.
Okay, so what are we paying attention to? We're paying attention to the root value. So the root value tells us what to do. So if we have a square root, we'll square it. If it's a cube root, we'll cube it. If it's a 10th root, we 10th it. Wait a minute, is that legal? I mean, 10th it? Okay, yeah, I just made that up. But we raise it to the 10th power. Is everybody all right? Right? So the root value tells you what you're going to do to get rid of it. So here's the square root. We're going to take and raise each side of our equation to the second power. Now remember, our first step was to isolate our radical expression. Here it was already done for us. Our second step is now to get rid of it by raising it to the second power or the root value. So now we have x squared equals, and then this 2 gets rid of that sign, okay? And whatever's underneath there comes out just the same way it is. So we have 5x plus 14. So now we have this situation where we have an x squared, an x, and a constant. We know that that's going to form a trinomial, and we got to get it in the right position so that we can take care of it properly. We know we're going to have to do some factoring, but we got to put it in the right place. So now we got to get it all on the same side of the equal sign so that we can factor it. Our leading term here is positive where it is, so we're going to move everything over to it so that it can be in the proper position. So we're going to subtract our 5x and subtract our 14. So here we have x squared minus 5x minus 14 equals 0. So now we have a working trinomial ready to be factored, however you're factoring it, so we can see what's going on. Now remember, we just used the quadratic formula, so if you feel comfortable using that, go ahead and do it, okay? Because that's, again, a way that we can solve this. Here, I'm going to go ahead and see about using factoring. I think I can do it. Nothing in common between all three parts. And I see it's not perfect because my last term is not perfect. So I'm going to go ahead and factor it, starting with what I know. I know my x squared is going to break up into x and x. I know that for sure. The factors of 14 that when I add and subtract together will give me my 5. Let's see, what's my factors of 14? 1 times 14, 2 times 7, and oh, that's it. Just those, right? So, right, clearly I see that if I subtract the 2 and the 7, I can get a 5. Those are factors I need to use. So I'm going to do a 2 and a 7. And I know I need to subtract them and get a negative 5. So the bigger number needs to be negative. Smaller number is positive. Here's my verbal check. I'm doing a verbal check because my leading term, the coefficient is a 1. Here we go. When I multiply my two numbers together, I get my negative 14 back. But when I subtract the two numbers together, I get my negative 5. All right, there's my check. So now I'm ready to solve, setting both of those factors equal to 0 using my zero product principle. I get x equals -2, x equals 7. So now I have two possible answers to my problem. Why are they possibles? Because when we're solving radical equations, we have to remember that radicals can't be trusted. They lie, okay? So we have to check them. So you have to take and check each answer to see if they are really your answer. So when we take and replace our x values back into our original problem, we'll see that one of these don't work. So when we check x equals -2 back into our original problem, we'll see that -2 equals the square root of 5 times -2 plus 14. Then we have -2 equals 5 times a -2 is a -10, and -10 plus 14, that is 4, right? But the square root of 4 is 2, not -2. Do you see that? That's a lie. That's not equal. So this can't be our answer. We got to cross it off. Okay, it gave us a wrong answer there, a lie. Now checking our x equals 7. So we have 7 equals 5 times 7 plus 14. 7 equals, this gives us 35 plus 14. 7 equals, adding those things together, and we get 49. And we know that the square root of 49 is 7. So 7 does equal 7. Yes, okay. So x equals 7 is our only answer here. Okay. So watch that. Radicals lie. So check all your answers. You only have 3 options, right? Either one work, all work, or none work. Okay? Okay, so our next one we want to look at is number 11. Number 11, we are looking at solving, again, our compound inequality, but this is the compound inequality that has our 2 inequality symbols in it at the same time. So number 11 says 11 is less than 3x plus 5, which is less than or equal to 13. And they want us to write our answer in interval notation. Now, when you come up against a problem like this, you can pretty much rule out a lot of your answers by just knowing what the structure of your answer is going to look like. With this particular problem, you know you can never have infinity in your answer. You can never have a U in your answer because this is not an OR problem. So anything that looks like those can't be your answer, okay? We know that this is an AND problem that's going to have an X in the middle, and we're going to have 2 specific numbers on the end. That means we're going to have 1 interval. And we know from our symbols here that my structure in interval form tells me that I'm going to have a certain symbol on the front and a certain symbol on the back. Can somebody tell me what those symbols are going to be? Using my interval notation, tell me what the structure of my answer is going to look like. Before I even do the problem, tell me what my answer should look like. I should have what on the front of my interval?
Should have a parenthesis.
Okay, a parenthesis on the front and what on the back?
A bracket on the back.
Okay, a parenthesis and a bracket. That is my answer structure right there. Before I even do any work, this is what my answer should look like. Okay, so if this is a multiple choice selection, anything that doesn't look like that can't be my answer. Is everybody okay? All right. You got to go with what you know for sure. And if you are weary and don't know for sure about that, then you're going to pick the wrong answer. Now let's get the right numbers. Now we got to solve for x. So here we are. We have a 3x plus 5 in the middle here. We want to get that x by itself. First thing we got to do, get rid of the 5. We got to subtract it from all 3 parts. All right. I don't recommend separating this problem into 2 parts, but if you feel secure enough doing it, that's fine. But I think you should keep it all together and just do it. You have 2 steps and you'll be done with this problem. Our first step, subtracting out what we don't need. Here we need to subtract the 5. 11 minus 5 gives us a positive 6. Is less than. Got 3x. Is less than or equal to 13 minus 5 is 8. Okay? Our last and final step. Divide by 3. Keep your eye on the prize, you guys. You're trying to get the x by itself, but you're not trying to move the x from in between your 2 symbols. Okay? So here we are dividing by 3. So we're left 3 goes into 6 2 times. Is less than x, which is less than or equal to. Can't simplify this. You're just left with 8 over 3. So we got our numbers now. We already got our structure. So we have a 2 and then an 8 over 3. And there's our answer in interval 4. Okay. Any questions? All right. Here we are picking up this last one. We're going to the next page. All right. I want to look at 26. 26 says the formula L equals the cube root of 36W relates to the weight W of one species of bird in pounds to its wingspan length L in feet. Find the wingspan L of a bird's weighing 6 pounds. So now, this problem goes back to chapter 2. When we looked at that bird wingspan problem, we had a bonus about it. We did it in the lesson. It was on the test. Look at how it appears again. Must be going to be on the final. Y'all better know how to do this problem. Okay. But it's to simplify it for us, though. Look at what they're asking us to do. It simply says, find the wingspan L of a bird weighing 6 pounds. They're giving us number 26. The formula L equals the cube root of 36W. They're telling us that the weight, which is W, is 6 pounds. So W equals 6. They just simply want us to replace the W with 6 and evaluate it. That seems pretty simple now, doesn't it? So we're solving for L. We're looking at the cube root. Do not remove the 3 from the root. We have a tendency of doing that, y'all. Okay, don't do it. They want to make sure that you're looking at the cube root. So we have 36. And then we're replacing the W with the 6. Okay. think about it now. We're talking about a cube root, not a square root. So in your calculator, this should be in a second function, or if you have a scientific, a graphing calculator, this is in your math button, okay, your cube root button. Go ahead and multiply this and find the cube root. Or look at what's happening here. We know that 6 times 6 is 36, right? And then we just plugged in a 6. So if you wanted to do it without the calculator, you can break down this 36 and say 6 times 6. And then here's the 6 we just plugged in. Isn't that 3 6s? So the cube root of this is just 6. Is everybody all right with that? Okay. Or get that big number, whatever that number is. That's what your calculator is for. Multiply 36 times 6, and you're going to get that nice size number. All right. You're plugging it in, whatever it is.
216.
216. 216. And then go into your calculator and find your cube root button. Again, we should know where it is at this point. If you don't, ask for help. Then you'll find the cube root of that, and it should be the number 6. And that is your answer. And to make it even more solidified, you could put the feet on there, since it comes in the dimensions of feet. It's interesting how I'm writing sideways now, isn't it? I just noticed that. I'm just starting the right side.
Getting tired?
I think so, yeah. I haven't eaten all day.
Mm.
Yeah, that's probably it too. Okay, one more problem and we're done. 27. 27 says rationalize the denominator. Okay, so rationalize. Rationalize simply means, in lay terms, as we saw in the lesson, it just simply means to get rid of the radical from the denominator. To rewrite our problem to where that can be anywhere it wants to be in the problem. It just can't be in the denominator. So they want us to rationalize. And they give us 3 over the square root of 5. Now remember when we were taking and multiplying our square root through, right, distributing it, and we use that little shortcut. This is where that shortcut is going to help us, where we're multiplying the same square root by itself. It kind of cancels it out. That's what's going to happen here when we're rationalizing. So we see in our denominator, we have the square root of 5. We just want to simply rewrite our problem. We don't want to change the value. We just want to change the appearance of it, all right? So when you want to do that, we always multiply something by the form of 1. And they're going to change the appearance of it, but not the value. So I'm going to multiply my problem by what's in the denominator. It's the square root of 5. So in the form of 1, I'm going to multiply by the square root of 5. I have to do it to the top, what I'm doing to the bottom. That's golden rule of solving, right? What you do to one thing, you do to the other. What you do to the left, you gotta do to the right. What you gotta do to the top, you gotta do to the bottom, right? Okay? So in the form of 1. So in the form of 1, I'm going to multiply by whatever is in the denominator. That's the square root of 5. Now I'm going to multiply across, and I get 3 square roots of 5. And then square root of 5 times the square root of 5. Remember, that's the square root of 25. But if we use our shortcut, we can cut out that middleman, and we know that it's just going to leave us the number 5. Now, when we look at the problem, are we finished? We need to see if we could simplify something. Here, I see that I have a 5, the square root of 5, and a 5 in the denominator. Can I cancel those 5s out?
No.
Why not? It looks so good.
But it's married under the radical.
Oh, you're right. Can't do it. Can't snatch somebody from the happy home. Okay? So can't do it. So here's our answer. All rationalized. Right there. And that's it. How do we feel about the final? Do we feel stronger?
A lot better than I was feeling a couple hours ago.
I feel a lot stronger about it. Real quick question. You said you had been recording this. Where would we go to review the recording?
I'm going to send out the link to the recording, so you can just click on the link and be able to view it. Mm-hmm.
Cool. That will be going through the email?
Yes. And then I think I'm going to try to tag it into the announcements page in Canvas.
Perfect.
And put it a couple of places probably.
All right. Cool.
Mm-hmm.
I just wanted to make sure.
Yes. Any other questions or concerns about anything? All right.
I'm good.
Yeah, good. So do that. What I'm also, the ones that we did and we focused on, those are the ones that really you need to
review.
Mm-hmm. Also feel free to do the online one. And the only reason I suggest that is so that you can get practice on submitting your answers into the portals and being able to use, check your syntax, making sure that you know how to enter in your fractions and all that stuff using the formatting tool, which is that yellow arrow. We know that pops up when you click into the box, so that there's no issues or major concerns when you are entering your answers during the test. Okay, so you'll get doing the online practice will give you practice on that part. Okay, but the practice in the textbook, of course, the one that we do in the back of our lesson, that's always the closest to the problems that you're going to have on the test. And of course, the ones we did today. Okay. All right. We did good. All right. Well, if there's no other questions or concerns, of course, if you could think of anything later on, just let me know. We may be sending out a small survey for you to fill out about the review session, so that we can tweak it. This is our first time doing it via, this
Zoom.
format. Yeah, Zoom. So we'd like to, get your feedback so we can see how we can make it better or tweak it for you and everything. So kind of look out for that as well. It may come in where the recording is and everything like that. Okay. So thank you so much for joining us, and I'll see you, or if I don't see you before the final, then thanks for being in the class.
Yep.
Thank you very much.
All right. Thank you.
Okay.
Have a nice day. Stay safe.
Yes, please be careful out there, guys.
So you want to stop the recording?
Mm-hmm.
Okay.
I'm gonna stop the share.